Hello everyone, welcome back to our college algebra course this semester. Today in this clip, I'll continue talking about chapter 6. I'll be covering two sections today, section 6.2 and 6.3 in our textbook. So let me start with 6.2. It is about one-to-one functions and inverse function. Okay, 6.2. One-to-one function and inverse functions. So let's first start with one-to-one function. One-to-one functions. So in short, you should be able to denote one-to-one function by one-to-one. Okay. So I'm going to use that notation instead of write one-to-one all the time. Okay, so first of all, let's start with function. What does it mean by a function? As I mentioned before, think of the function as like a machine where the input is x, and whenever you put the input into a machine going to follow some formula, some recipe, is going to give you back the output y. Okay, and function is going to satisfy one condition. That for each input x, you're going to have exactly one output y. Say y equal to 2x plus 1. See? For each value you're looking for x, this is a function saying, well, I'm going to double the x, take the x times 2 and add 1 and give you the y. That's a function. Or something like y equal to x squared. Whenever you give an input x, what do? You time by x itself, x squared, you got the y value come out. Those are functions. Today, in this topic right here, we talk about one-to-one function. Okay? For the definition of function, we never restrict condition for the input. We only restrict condition for the output. Each input can only give you the exact one output. But we never say that each different input going to give you different output. It could be the case that two different inputs give you the same output. That's okay. Say this example right here. I plug in x equal to 3. I got y equal to 3 squared, which is 9. X equal to -3, I still have y equal to -3 squared, which is still 9. All right, so two different inputs give you the same output. That's okay. It doesn't violate the conditions for the function that each input gives you the exact same output. It's not the case of 3 sometimes give you 9, some other time 3 give you 7, and that's not a function anymore. We control the outputs. Okay, but in here, different input can give you the same output, and that's to satisfy the condition for the function. And to restrict that case to happen, actually this one right here, because 2-to-1 function. Okay, two different outputs give you the same input. Two different inputs give you the same outputs. I just say that. Okay, now we have a special type of function to learn today called what? A one-to-one function. Now we are restricting the condition for the input as well. We don't want a case of two different inputs give you the same output. One-to-one means what? One input give you one output, right? So different input is going to give you different outputs. So this function right here is not one-to-one because I can have 3 and -3 different inputs give you the same output, not one-to-one. So one-to-one means what? Different input give you different outputs. Same input, of course, same input give you the same output. Okay. So let me just write down kind of formally. A function f of x is one-to-one if I'll write this info in two different inputs. Say x1 is not equal to x2, right? On different inputs. Give two different output. Okay, so f of x1 is not the same as f of x2, or this is y1 is not equal to y2. It's not a formal way to write, but it just help you to get the idea of it. 1-to-1 means what? 1 in, 1 out. Never the case of 2 in and 1 out. Okay. different thing in, different thing out for sure. Never the case that different thing in give you the same thing out. All right, 1 to 1. Different in thing is different input give you different outputs. That's all. And this is a 1 to 1 function. And how do you know if a function is 1 to 1? You have something called the horizontal line test. Horizontal line test. The way we test is very similar to the vertical line test. The vertical line test is to test to see if the graph is a graph of function or not. Now we have a function already. We want to test to see if that function is 1 to 1 or not. So say you have a function like this. You draw a horizontal line. You find that the horizontal line intersects the graph of 2 points. So it's not 1 to 1. Okay, because it's failed the horizontal line test. The horizontal line intersects the graph at 2 points or more. See, 2 different inputs give you the same output. Okay, if you have a graph like this, okay, let me draw it better, like this. Okay, and you draw any horizontal line, it passes because it's only intersect the graph at 1 point. And this is 1 to 1. All right. Okay, and you see what this function right here is just increasing, like going up forever. Not forever, keep going up. That's what I'm trying to say. You see what happened with this one right here? It's going down, go up, it's on direction. Then some point it's gonna the vertical line will intersect the graph at 2 points. Okay, and that give us a hint to have some properties about 1 to 1 function. If f of x is a monotonic, means what? Increasing or decreasing? Increasing or decreasing means what? It's always going up or always going down. It's never go up and then change direction, go down, or the other way around, go down, change direction, go up. Then it's always just up or down. Then f of x is 1 to 1. Okay. The other way is not right, okay? If it's 1 to 1, you cannot say it's always increasing or decreasing. I can have a function like this. Increasing and then decreasing, you see 1 to 1. Okay, that is about 1 to 1 function. And all you want to get in here is a 1 to 1 function. It's a function that gives you different inputs, going to give you different outputs. Okay. Now let's move on to the second part of this section. We're going to talk about inverse function. Number 2, inverse function. Okay. We have a function already. Say this is my function. Okay, f of x. And you plug x in, you get y out. X come in, y come out. Right. This is a function. F of x, y equal to f of x. Whenever you plug an input, x in, you got a y out. Okay? And you wonder, is there any way that I can find a function that reverses the procedure? There's another mysterious function right here, such that when I plug y in, I got x out. And if this is the case, if you can find a function like this, this is called the inverse of the original function, because this is what x in, y out, right? The reverse of it, the inverse of it is what? Y in and x out. And if you can have a function like this, because the inverse function, and guess what? It turns out that 1 to 1 function can give you the inverse. See what? X in, y out, right? Different x give you different y. And you don't have the case of 2x give you 1y, then you can find the other way around. 1y give you 1x. Because if it's 2 to 1, 2x give you 1y, the other way around is going to be what? 1y give you 2x. It's not a function anymore. So you see what? 1 to 1 function going to give you an inverse. And by the way, the inverse function is going to be denoted this way. F to the negative 1 like this. And this is called the inverse function. Okay? So let me just write down kind of formal for you. given a function f of x, okay? So I have a function. If f of x is 1 to 1, okay, I have to indicate that condition because only 1 to 1 function can have the inverse, okay? If f of x is 1 to 1, then there exists an inverse function, of f of x denoted by f inverse of x, such that if y equal to f of x, then x equal to f inverse of y. So what we're saying is we have a 1 to 1 function, okay? And if the function is 1 to 1, we can find an inverse of this 1 to 1 function f of x. And what do we mean by the inverse function? For the original function right here, you plug x in, you got y out, right? The function f right here, x the input, y is the output. Then for the inverse function, you plug y in, you got x out. And this is kind of definition of the idea of inverse function. Okay? You have a functions 1 to 1, and we can find the inverse. And that's the definition. Okay? So the second part is just how to find the inverse. So let's just put in here. How to find the inverse of f of x. Okay. The idea of finding inverse is what? We are interchanging the roles of input and output. X becomes y and y becomes x. You see in here what? X in, y out, right? In here what? Y in, x out. So output y for f becomes the input for f inverse. Okay? So if you have a function, say f of x, let me give you an example. Okay? I'm going to give you an easy one. F of x equal to 2x plus 1. So instead of writing f of x, let me write this way. Y equal to 2x plus 1. Because the letter y is easier to write than f of x, then I can find the inverse. Y, think of y as the output, and x is the input, right? Now to find the inverse, but you've got to interchange y and x. Interchange y to x. Okay? So what? X equal to 2y plus 1. This is going to be the inverse function right here. You see what I'm doing? I change output y to input x and input x to output y. And this is going to be the inverse of the original one. Original one is y equal to 2x plus 1. And by the way, this is 1 to 1 because what? This is a line, right? It passes the horizontal line test. Yes. And you change y to x and x to y, you have this. And then you're going to solve for y. Oh, rewrite until the y, so you say solve for y. Okay, so what do? I subtract the 1 on both sides. X minus 1 equal to 2y. So y is equal to x minus 1 over 2. Okay, and this is the inverse. So you're going to write the inverse function as inverse function. The inverse function is f inverse of x is equal to x minus 1 over 2. Okay? And I claim that this is going to be the inverse of that one. Okay, let's demonstrate the property of those two things. I have the function f of x on the left hand side, the function f inverse of x on the right hand side. Let's try to plug in some input. See what you have for the output. Input x, output y, input x, output y. Okay? So if this is f of x equal to 2x plus 1. This is equal to x minus 1 over 2. I plug in 1 in, 0 in here. This is 0. 2 times 0 is 0, plus 1 is 1. Plug 1 in, I got 2 times 1 is 2, plus 1 is 3. Plug 2 in, I got 5 out. Try negative number. Negative 1 in, negative 1 times 2 is negative 2, plus 1 is negative 1. Try negative 2 in, I got negative 3 out. Okay? So So for the original function, 1 in, 0 in, 1 out, 1 in, 3 out, 2 in, 5 out, -1 in, -1 out, -2 in, -3 out. Now, I'm going to try the inverse function. I'm going to try those outputs for the original function. That's the input for the inverse. If I plug 1 in, see what I got? 1 in here. 1 minus 1 is 0, divided by 2 is 0. You see? This is 0 in, 1 out. The inverse is what? 1 in, 0 out. Try 3 in. 3 minus 1 is 2. 2 divided by 2 is 1. Okay? Try 5 in. 5 minus 1 is 4, divided by 2 is 2. Try -1 in. -1 minus 1 is -2, divided by 2 is -1. Try -3 in. -3 minus 1, -4, divided by 2 is -2. You see? That's really the inverse of each other. Alright? So that is the meaning of the inverse function. It's opposite procedure. Input becomes output and output becomes input. Now let me show you some properties of the inverse function. Some properties of inverse functions. The first property. The domain of the function f. This is the domain of the function f right here. This is indicates something. The domain of function f is the same as what? Is the range of the function f inverse. You see, because we interchange the role, right? Whatever you plug in for the function f, for the original function will be the output for the inverse function. And then the range for the original function f is going to be equal to the domain of the inverse. Whatever the output for the original function now becomes the input for the inverse. Okay, that's the first property. The second property is this. If you compose the two functions, f compose f inverse, say of x. So you plug x into f inverse, and then you compose. If you use the output for f inverse to plug into f, it's going to be the same thing. Then same thing the other way around. F inverse composed to f of x is also equal to x. And by the way, this is the problem that people use to test for inverse function. It's the idea, right? X in here, you plug into the function inverse first. So you plug 1 in to this inverse function. You got 0 out. You use a 0 as the input to plug into the original function. You see, got back 1 out. So 1 in, 1 out. Okay. So you plug 3. Plug 3 in here. F inverse of 3 is 1. So this is 1. And you plug 1 into f. Plug 1 into f. You got 3 out. So 3 in, 3 out. Of course, the other way around it still works. So you plug 3 in here. 3 into f. I didn't have 3. So how about 2? Plug 2 into f right here. I got 2 right here. Plug 2 in. I got 5 out. Okay? And now if I use 5 to plug into the inverse, I still got back 2. So 2 in, 5 out as the intermediate value. Use 5 plug into the inverse, you got 2 in. Okay. Plug 2 in here. F of 2 is 5. And then f inverse of 5 goes back to 2. So whatever you plug in, you get the exact same thing out. Okay? So this is a way to test for inverse function. You find the composite of the two functions in the two orders. Okay, f composed f inverse and f inverse of f, and whatever you plug in, you got the same thing out. That's gonna be the inverse function of each other. Let me give you an example in here before I move on. I'm going to use the same example right here. F composed f inverse of x. Okay, so we learned that before in section 6.1. F inverse of x is x minus 1 over 2, right? And this becomes the input for f. So it's going to be 2 times x minus 1 over 2 and then plus 1. And you can simplify this. The 2 cancel out. I'm going to write down here. Then x minus 1 plus 1, which is equal to x. See? F of f inverse of x equal to x. Similarly, f inverse of f of x. Now we do the opposite order. X first, right? Plug into f, I got 2x plus 1. And I'm going to plug 2x plus 1 into the f inverse. So what? 2x plus 1 minus 1 over 2, which is 2x over 2, which is 2x. So either way, you have the same thing as you plug in. It's called the inverse function. And by the way, you want to test for inverse function is both ways. You have to do two components. F composed to F inverse composed to F. Okay. The third property. Property number 3 is F inverse, and then inverse x is equal to f of x. So the inverse of the inverse come back to our normal function, right? Let's see, x in, y out. The inverse of this is y in, x out. Then the inverse of y in, x out is back to x in, y out. So inverse of the inverse. Gonna get back to our original function. So you never have third function involved in here. Always its function and the original function and its inverse. Okay. Property number 4. The graphs of f of x and f inverse are symmetrical about the bisector y equal to x. Okay, we'll give you an example. Say f of x equal to x cubed. Then let me show you the graph of this thing. It look like this. I have to draw it for a moment. My x-axis right here. This is the y-axis right here. Let me use how about a green color. The graph of this function is going to be like this. Okay. This is y equal to x cubed. And you see, passing horizontal line test. So it is really a one-to-one function. Okay, so one-to-one function, we can find the inverse. So how do we find the inverse? We learned that a minute ago. We have y equal to x cubed. Interchange the row of x and y. We got x equal to y cubed. Now we solve for y. Have to solve for y. Take the cube root on both sides. Equal to y. The inverse is cube root of x. Okay. F inverse is cube root of x. And let me show you how to draw the graph cube root of x. I'm going to use a red color. The graph would be like this. Okay. So the red one is y equal to cube root of x, which is the inverse of the green one. Okay. And what we're saying here is what? The two graphs are symmetrical about the bisector, and this is the bisector. This is a line, okay? This is y equal to x, the bisector. Imagine that if you flip the green curve over the blue curve, you have the red one. This one right here. That one. This is the origin. And this is the last properties that I think that we have in here. Try another example. The one that I just showed you a minute ago. How about this one? Y equal to 2x plus 1, right? So this is f of x. F of x, f inverse, we just calculated it. This is x minus 1 over 2. Let me rewrite it this way. X over 2 minus 1 over 2. Or this is 1/2 of x minus 1/2. Looks like a line, right? It's a line with slope of 1/2 and y-intercept negative 1/2. Let me show you the graph of the two lines. X-axis, y-axis. 1, 2, 3, 4, 5, 6. I'm going to use green color for the first graph. Right here, y equal to 2x plus 1. Intercept is 1, slope is 2, right 2, run 1. Okay, so this is the first line. Alright, this is y equal to 2x plus 1. Now I'm going to use red color to show you the second graph of 1/2 of x minus 1/2. Minus 1/2 is right here.